Okay, so these are the exam 2 review slides for fall 2016. So this is the what is it? These are going to be the free examples of some of the free answer parts you're going to see. Now for the multiple choice, stuff like that, so those are going to be a lot of those concepts and trends, particularly from Chapter 2 and Chapter 3. We talked about a lot of trends like solvents and, which one's more soluble in water, which ones are, things like that, orbitals and that kind of stuff. All that's going to be covered in the multiple choice, stuff like that. But these particular ones are going to be the free answer part. Stuff like that. So one of the things we're going to do, right? So we talk about atom geometry. So in this case, it'll actually say shape of the atoms. Okay, so that's what we'll have a big arrow going to the atom and tell me the shape. So there's going to be two parts, right? You're going to want to see the base structure, and then what you're going to want to do is you're going to want to cover those wherever you have a set of lone pairs, cover up one of those sides, stuff like that, until you get your structure, okay, your actual molecular geometry, okay, stuff like that. So for here, right, stuff like that. So the first thing you're going to want to do is you're going to want to find how many groups you've got, okay. So remember, any bond set, so single, double, triple bond set, that's just considered one group. So here we've got 1, 2, 3 groups, okay. So the single bond's a group, a double bond's a group, single bond's a group, okay. So we have 3 groups, okay, no lone pairs, okay. So we have 3 groups, right? So that means that it's the base structure is trigonal planar, okay. So by that, now since we don't have any lone pairs, right, there's nothing to cover up, so that means that the molecular geometry is trigonal planar, okay. Now for this one, right, so we have how many groups, right? Well, we have the bonds, so that's 2, but then a set of lone pairs is also considered a group. So we have these 2 sets of lone pairs, right? So therefore we have 4 groups. The base structure for 4 groups, right, is tetrahedral. If I can spell, tetrahedral, okay? But we're going to cover up 2 of those groups because we have 2 sets of lone pairs. Okay, so when you cover those up, what's left is it looks like it's straight, but remember tetrahedrons, they're all coming out in, they're coming out 3-dimensionally. It actually ends up becoming bent. Okay, so even though it looks like it's straight, if you look at something bent, right, straight, it's going to be that, but in fact it's like this, right? So that looks straight, bent, right? So like that. So. Okay, so like that. So wherever so remember your base structures: tetrahedron, trigonal planar, and linear, right? So like that, and then wherever you have lone pairs, cover them up. Cover up one of those lobes. So like that. So okay. Now again, if we look for hybridization, right? Again, we're going to look at those how many groups we've got, but that means. But instead, what you're going to do is you're going to look at how many letters you have. So you're going to start with S and then keep adding P's until you get the appropriate number of letters, right? So for this carbon, right, again, we have 3 groups, okay? This group, that group, that group, right? So we need 3 letters, okay? So we need S, P, P, right? So 3 letters, and so the hybridization is sp2. Okay? Now for this one, again, we're going to have 1, 2, 3, 4 groups, right? So with that, so 4 groups, right? So that means we need 4 letters. So it's S, P, 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 right? So 4 letters. So it becomes sp3. There you go. So now for these, the thing that don't forget about is on making sure that you have everything drawn, right? So with that, so for the other ones and for this one, remember with skeletal structures, I don't have to draw the CH bonds. Like that. So, but they are still there. Okay. Now for here, determining how many sigma and pi bonds you've got, now it's going to be pointing to a specific bond. I know in some of the homeworks it said like how many total. I'm just going to look at a specific bond. Okay. So with that, so the first bond that always gets laid down is going to be a sigma bond, and any one beyond that is going to be a pi bond. Okay. So this first one here, right, that's going to be a sigma bond. Okay. This second one, okay, is going to be a pi bond, right? So I have 1 sigma, 1 pi, and if you add it up, right, it's 2, right? You have a double bond, okay? Same thing happens down here, right? With that bond there, right? This first one is a sigma, right? But I don't have any additional bonds right there, right? So with that, so there's 0 pi bonds, right? That makes sense. If you add them up, it's just 1, okay? So this one has 1 sigma, no pi. This one has 1 sigma, 1 pi. There you go. Okay. Now, if you want to look at ortho-meta pair orientation, right? So ortho is going to be right next to each other. Okay. Meta, you're going to have a carbon group in between it, right? So that between the two groups, and then pair is going to be opposite each other. Okay, and they don't have to be the same groups, right? So, but that's just two groups. They don't have, like in this case, all of these are just chlorines, but they don't have to be. Okay, so but like for here, right, they're right next to each other, right? So that there's no carbons in between them. So like that, and so this is ortho. Okay, and in this case, right, they're opposite of each other, right? So this is a para. Not too bad. Okay, now. The other thing you're going to see is you're going to see a lot of these. You're going to see a lot of names, right? So one from each of these types. Okay, but again, we're going to be talking about these, right? So, but again, we do the same rules, right? So, about that. So, first thing, right? So, we do the main chain. It has to include the double bond, right? So, 1, 2, 3, 4, 5, 6, right? But we can do right 1, 2, 3, 4, 5, 6, right? But that main chain does not have the double bond in it, so it has to be that. Okay, so by that, so 1, 2, 3, 4, 5, 6. Okay, so by that, so C6. So that becomes, or base name would be hexene, or excuse me, hexane, and so it becomes hexene, because base name is hexane, right? Change that suffix to hexene, right? But again, we're going to need to have that alkene in there, right? So but that we need to know where that alkene starts, right? But then we also have the 2-carbon ethyl group here. Right, so 1, 2. Okay, so the side closest to the double bond, right, becomes carbon 1, right? So it becomes 1, 2, 3, 4, 5, 6, right? So with that, so it becomes so the double bond starts at 2, the ethyl is at 3, right? So with that, so the name's either going to be 3 ethyl, 2 hexene, right? Or, and again, I only need one of these. I don't care which one. You can do 3 ethyl. Hex 2-ene. Okay? Either one. It doesn't matter. Now for the cyclo, okay, so for the cycloalkenes, right, so with that, so either this is going to be 1 or that's going to be 1, but that means that the other side of that double bond has to be 2. Okay? So again, we'll do this in red, keep it consistent. So, right, so that's a 5-membered ring, right? So with that, so C5, right? Which would normally be pentane, right? But since it's a ring, right, we have to put cyclo out front, okay? Pent, to say it's 5 carbons, and then it has a double bond in there, so it's ene. So cyclopentene, okay? But again, we're going to have the alkene, right? And then we have 2 methyl groups, right? So 2 independent methyl groups. Methyl. It's not an ethyl group. It's not an isopropyl group. It's 2 independent methyl groups. Okay. So one side of this double bond is going to be 1 or this one, right? So let's say it's this one here. So let's say that's carbon 1, right? That would mean that's 2. So we have to keep going around. So 1, 2, 3, 4, 5, right? So that means both of these methyls are 5. Okay. Alternately, if we said that's it, that one 1 and this one 2, we're going to keep going around. It's 3, 4, 5, right? So that means, again, this would be at 1, but now it's 3, 3. Okay, so we're going to add them up, 11 versus 7, right? So we're going to take those numbers there. Now, again, you don't necessarily, because there's just the single, there's just the one double bond in there. You don't have to put the 1. I think it's a good idea, especially when you're just starting to get into that habit, but you technically don't have to. But we're going to combine those methyl groups. We have to do the 5, 5 to tell me where both of those are, right? If you have a dimethyl, right? If it's a di, I need 2 numbers, even if it's the same number. Okay, and then it becomes 1 cyclopentene, or 5, 5 dimethyl, cyclopent 1-ene. Okay, I'll take either one. Now for the alkyne, right? So but that's well, it's just that you just have all these carbons just in a chain, right? So that's going to be our main chain, right? So 1, 2, 3, 4, 5, 6, 7, 8, right? So C8, right? So this becomes, right? So with that, so octane, right? But because we have a triple bond in there, it becomes octyne. Okay, so we have the alkyne, right? So with that, and then we also have the fluorine, so it becomes fluoro, right? So with that, and so these are going to be, right? So this end is closest to the triple bond, so that's going to be 1. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the alkyne starts at 3, the fluoro is at 7. Okay, so it becomes 4 fluoro, 3 octyne, or you could do 7 fluoro oct 3-ine, or octa, doesn't matter. Excuse me, oct 3-ine, something like that. So, or you could do octa 3-ine, doesn't matter, something like that. So there we go. Now, if you've got multiple either double or triple bonds in there, right? So for that, we're going to take both of those into account, right? But it's going to include those, right? So 1, 2, 3, 4, 5, 6, right? We can't go 1, 2, 3, 4, 5, 6, right? Because we're missing that triple bond, right? So we're going to need to do that as our main chain. Okay, so 1, 2, 3, 4, 5, 6, right? So C6, right? So that would be hexane, right? Right, but because we have, it would be hexa. Okay, but we have two triple bonds. It would normally be ine, right? So but since we have 2, it would be hexadiene or hexdiene, either one. Okay, but again, we have 2 alkynes. We have 2 alkynes. We're going to get the positioning on those, alkyne. But then we also have, again, this ethyl group here that we have to number, right? But again, this side is closer to the end than this double bond, right? So with that, so our number is going to go 1, 2, 3, 4, 5, 6. Okay, so the first one starts at carbon 1, the other alkyne starts at 4, right? And the ethyl's at 3, right? So it becomes 3 ethyl, 1, 4 hexadiene, okay, or 3 ethyl hexa 1, 4 diene. Okay, we have 2 triple bonds in there, right? So we need the di, and you need to let me know where those are. Okay, so I'll take either one. If you put just hex there, that's fine. So, okay. Now the last type is when you have a double and a triple bond. Okay, now for whatever reason they decided to give the double bond priority over triple bonds. Okay, so with that, again, our main chain is where pretty much just the carbons are is here, right? So C5, right, which would normally be pentane. Okay, but we have so it's going to be pent, but again we have a double bond, so that just becomes En. Okay, and the triple bond becomes YNE. Okay, so we have 5 long, we have a double bond, we have a triple bond, right? 5 long, right? Double bond, triple bond in there. Okay, so with that, so we're gonna have to say where that alkene is. Alkene starts, and the alkyne starts. Okay, but then we also have, right? Don't forget that chloro there. Okay, and because double bonds have priority over triple bonds, we're looking at the end close to the double bond. Well, it ends up being this end, so it becomes 1, 2, 3, 4, 5, right? So the alkene starts at 1. Those are parentheses. The alkyne starts at 4, right? And the chloro is at 2, right? So with that, so it becomes 2 chloro, pent, 1 N, 4 ine. Okay, or you could do it 2 chloro, 1 penten, 4 ine. Okay, it's kind of a mouthful, but you have all those parts, right? So we have a main chain that's 5 long, 2, 3, 4, 5. We have a double bond in it that starts at carbon 1. we have a triple bond that starts at carbon 4, and oh hey, just for spice, we have a chloro group at 2. But that's there we go. Good luck on the test.